All right, let's start kind of talking our way through this warm-up. The area of a square with a side length of 12 inches. How do we find area for a square? Side squared. And how big is our side again? 12. So we're going to do 12 squared. And what is 12 squared? 144. So the answer here is 144 inches squared. For number 2, we have a rectangle that has a length of 10 feet and an area of 330 square feet. So let's just start off with, how do we find the area of a rectangle? Length times width. So there's 2 pieces that we can fill in this formula. We know what the area is, so I can put something in the place of the A. What should go in the place of the A? 330. So 330 equals, can we put in anything for L for length? 10 times W. So now what do I need to do to isolate the W? Divide both sides by 10, yes. And what is 330 divided by 10? 33. Should we put units with that? Feet. So 33 feet is equal to the width. Very, very nice work. All right. The homework that you guys picked up on your way in the door is going to be due tomorrow. It is just the front side, and we should have some time towards the end of class when you can even work on that a little bit. It should be a fairly quick homework for you after we go through the notes today. So go ahead and pull out your notes packet. Up at the very top, there's room for your name and the class period, and then also the test date. This will be your last test before final exams, and as of right now, it's tentatively scheduled for May 15th. So 5/15 is the tentative date for your last regular test. So today we're going to talk about cross-sections and solids of revolutions. Cross-sections first. A cross-section is where we take a solid object, in this case they have a pyramid shape, and we're going to slice through with a plane. Have you guys ever seen or played the phone game like, Fruit Ninja? Where it slices through the fruit and you can kind of see what it looks like on the inside as it falls down? That's what I want you to think of when we're talking about cross-sections. We're going to slice through this shape, and we're going to look at the inside of it. What shape, what two-dimensional shape does it make when we slice through? So this first picture here, where the pyramid is slicing kind of parallel to that base, depending on whether the base is a square or a rectangle, I can't really tell from the way the picture is drawn, but if you were to slice it parallel to the base and then you were to look at that cut edge, it's going to make either a square or a rectangle. Again, I can't tell what shape the base is, so I'm not really sure. If we were to slice it diagonally like this, it's going to make a rectangle or a trapezoid shape. If we were to slice straight down, perpendicular to the base, through the vertex, through that top point, it's going to make a triangular shape. We say that an object has a plane of symmetry if the figure can be mapped onto itself by a reflection in a plane. Basically, if you can chop it in a spot, and then you would be able to reflect it, kind of fold it over on itself, and it would match up exactly. Then it has a plane of symmetry. Very similar to a line of symmetry where you would fold it over and it would match up, like with tracing paper. All right, so let's look at a couple objects now. We want to describe the plane or planes of symmetry for this rectangular prism. So I want to talk about where we could slice this object so that if I were to fold it over next to itself, it would match up perfectly. Do you guys see anywhere that I might be able to slice this? Right through the middle, like if I were to cut it right here, that would be a plane of symmetry. So we're going to describe that as one plane of symmetry. Parallel to the bases through the middle. Where else could I slice this? Top straight down, so I could cut it kind of like right here, right? If I were to slice it like this straight through. Could I cut it the other direction straight through? Like this way? Yeah, I could slice it this way here. And that would also be a plane of symmetry. So we have two planes of symmetry. Perpendicular to the bases. Through the midpoints of the base edges, opposite base edges, sorry. No, he's not. Thank you. All right. So we have one plane of symmetry that goes through the middle, like this right here. One that cuts down from the top through the midpoints of those base edges, and one that cuts down through the top through the other two opposite base edges. So when I first looked at this, I thought, well, I wonder if I can cut this diagonally this way. The problem with doing that is they didn't tell me that this was actually a square on the base. It might be a rectangle. If it's a rectangle and I cut this diagonally, it wouldn't be able to fold over and like stand on top of itself perfectly. And I just can't tell, like maybe this is 5 centimeters and this direction is 5.1 centimeters. That would be just enough to throw it off. So this particular object has 3 planes of symmetry that I know for sure. Now, if they had said that this was a regular rectangular prism, then I could do that. Because regular means what when we're talking about an object again? All sides and angles are congruent. So if they'd use that word regular, then I would know that the top 2 bases have all sides and angles congruent. What'd you say? Here? Yeah, we've got rectangular, but not that word regular. Let's look at another example right below this one. What kind of a prism do I have here? Pentagonal, yeah, pentagonal, pentagonal. And what does it tell me about that pentagonal prism? They do use the word regular this time. So now I know that all of these sides are congruent to each other. And I want to describe all the planes of symmetry that we see here. Where's somewhere that I could slice this object so that the 2 halves would be identical? You could fold one on top of the other and they'd match up perfectly. Right through the middle again. So I could slice it here. There is one plane of symmetry. Parallel to the bases through the middle. Where else could I slice this? top down. So I can go through this vertex and then the midpoint of the side opposite it. I could cut it right here. That would allow me to take the right side and I could flip it over on top of the other side and they'd match up 100%. Could I do that anywhere else on the top and bottom? Could I go through another vertex and midpoint set? Remember, all those sides are congruent. So I could go from this midpoint, or sorry, this vertex to this midpoint. With the way they've drawn the picture, it doesn't necessarily look like they would match up perfectly, but again, we've kind of got a perspective drawing here. Because they use that word regular, I can go through any midpoint vertex pair that is opposite each other. So how many of those do I have? I just drew 2. How many more of these could I draw in? 2 more. Here would be one of them. And it would come down and cut this here. Where's another one? I got this. Are there any others? I see one last one that we could do. There's this vertex and this midpoint right here. So how many ways can I cut it through the top? I can cut it 5 ways through the top because I'm going to go through the midpoints of all 5 edges and I'm going to hit all 5 vertices. So I've got 5 planes of symmetry. Perpendicular to the bases. Through a vertex. And the midpoint. Of a base edge. Of the pentagonal bases. So that gives me a total of how many planes of symmetry for this regular pentagonal prism? 6 total planes of symmetry. 5 that I can chop if I go from the top down, and then 1 through the middle that's parallel to those bases. Cross-section, again, is what shape do I get when I slice it? So when I slice it parallel to the base, when I make this cut right through the middle, if I were then to pick up where I've sliced it and look at that shape, what would I see? If I were to slice it right through the middle here, and then I were to look at that cut edge, what shape would I see? A pentagon. This would be the same as my base. What about when I make those vertical cuts, the ones that are perpendicular to the base? If I were to slice it through this pentagon so that it's perpendicular to the base, I go through the top and the bottom, and I were to look at that cut edge, what shape would I see then? I'd see a rectangle. Because these 2 sides over here would be congruent, and then I would see the top and I would see the bottom. Again, I'm looking at the cut edge. If if we were, let me see if I can sketch this out. I'm not super good at this. All right, so this right here is what I would be looking at if I were to slice through, so that I, like, maybe I went through these two vertices here, so that I just have like this triangle shape left in the back, but I'm looking at this cut face right here. I would have that rectangle shape there. All right. Let's go ahead and flip the page, and I'm going to look one more time at its shape and see what we get when we cut through it. If I were to cut this cone parallel to the base, so like this, parallel to that base, so horizontally with the way this is oriented, and I were to look at that cut edge, what shape would I see? A circle. What if I were to cut it perpendicular to the base through the vertex? So this way. A triangle. Perpendicular to the base through that top point means that cut edge would look like a triangle. Now, if I were to look at the object as a whole, the back side of that cut would have this curved half circle shape to it. But if I'm just looking at the cut edge, like if I used it as a stamper, I would be stamping triangles then. All right, nice work. That's what we're doing as far as cross sections go. Planes of symmetry, and what shape do we get when we slice through it. Next piece that I want to look at, and this is the last thing that we're going to do for today, is solids of revolution. A solid of revolution is a solid figure obtained by rotating a plane figure or curve around an axis. The shape of the solid of revolution depends on the location of the axis and the shape of the plane figure or curve being rotated. You can determine whether a three-dimensional figure could have been created by rotation by identifying whether the solid figure has an axis of symmetry. Have you guys ever seen an airplane at rest, like that has propellers? Or anything, like you could even look at a little drone that has propellers, and when the propeller is still, it just kind of looks like a straight line, right? And when the propeller starts to spin, it spins so fast that you end up seeing a shape that's not a straight line. And I dropped my pen. What shape do you see when that propeller starts to spin? You see a circle. The object itself being rotated isn't a circle, but when it spins that fast, you see this circular shape. That's the kind of thing that we're going to be looking at. If I take this shape, this two-dimensional shape, and I spin it really fast, what object would I see while it's rotating? So number 4, part A. I want to look right here. This is before the revolution. So I have like a square or a rectangle sitting on top of a line. Thank you. And we're going to rotate it about that line L. So line L is this horizontal line. My rectangle is sitting on top of it. And so when I spin this, it's going to go around this way. And so this right here is what they're showing you after we've started rotating that line, that axis, and it's spinning really, 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 really fast. We would see this object right here from the rotation. What would we call that object? It's a cylinder. A cylinder is kind of like a soup can or a soda can shape. Almost, if it had a flat top on it, like a Coke can. Not like the water bottles, but like the can where it's flat on top and flat on bottom. Almost, if you took the lid off, then it would have a cylinder shape. What about if I were to take this triangle right here and I were to spin it around this vertical line L, it's going to turn into a cone shape because this side is going to make a circle shape as it rotates, but the top isn't going to go anywhere. It's touching the line. It doesn't have anything to really spin around. It's firmly attached there. So we would get a cone shape here. After revolution, it's going to kind of look like this as this corner spins around to here and then spins back to itself. Do you guys see that kind of cone shape to it? So some of the solids that we're going to be studying in this second part of Module 11, 11B, we're going to talk about prisms. Prisms remind me a lot of cans, except they have straight sides instead of curved sides. So a box would be an example of a rectangular prism, like a cereal box. Or we looked at just a moment ago this hexagonal prism. Didn't go back quite far enough. We had a hexagonal prism, where it's a pentagon. Pentagonal prism. Pentagon top, pentagon bottom, and then straight sides connecting them. We're going to talk about pyramids. We're going to talk about cylinders and cones. And we're going to talk about spheres. So those are several of the objects that we are going to be studying in detail. Your homework that is due tomorrow, the worksheet that you guys picked up, you're going to go through and you're going to do a couple problems like what we just did with the examples. You're going to name how many planes of symmetry and describe how you would cut the object to get those planes of symmetry. So that's the first three problems. Tell me how many planes of symmetry there are and how you would cut it to get those planes of symmetry. The next three problems, I want you to tell me if you were to slice it the way those planes are showing through those solid objects, through the pyramid, through the cone, through the rectangular prism, what object would you see? What two-dimensional shape would you see on that cut side? And then I also want you to then tell me about revolutions. If we were to take the object pictured there and the line and we were to spin it about that line, what three-dimensional object would you get? You guys have the remainder of the time to work on the homework. I'm also going to pass back the test so you guys can see how you did on the test from yesterday.